Our next session is a faculty-led panel entitled, Where Will Our Cars Take Us? Advancements in autonomous driving has exploded during the past 10 years, leading to a race in technology innovation, demonstrations, and novel applications. Our panel will discuss this evolution, the role of Cornell and of industry, and the future of where our cars will take us. We have 4 panelists today for this topic. The first is Mark Campbell, who is the John A. Mellowes Professor and S.C. Thomas Z. Director of the Sibley School of Mechanical and Aerospace Engineering. We have Nidhi Kalra, Cornell Class of '02, Senior Information Scientist at RAND Corporation. We have Aaron Nathan, Cornell Class of '06, Founder and CEO at Point One Navigation. And we have Ankit Patel, MBA Class of 2012, Senior Product Manager at Nvidia. Mark recalls the first time his students took him for a ride in their autonomous car at 2 a.m. in the vet school parking lot at 15 to 20 miles per hour backward. At home, he keeps his kids entertained by talking with them in movie quotes. I want to talk to him at break. Nidhi is thankful for Cornell's sure, why not attitude every time she had a crazy idea, like starting an autonomous underwater vehicle team. When not at work, Nidhi can be found hiking up Coit Tower with her husband and 2-year-old daughter. Aaron remembers fondly the semester he spent with 13 other Cornell students at an abandoned military base just north of Cornell, working on autonomous cars. He is grateful for the undergraduate project team program in engineering and to the awesome professors who support it, with a special shout out to Ephraim Garcia, Dan Huttenlocker, and Mark Campbell. Ankit is thankful for Cornell for challenging him, believing that if it doesn't challenge you, it doesn't change you. He remembers fondly getting stranded by a massive snowstorm on the last day of his Cornell executive program in Palisades, New York, and celebrating while snowed in with his fellow students. I would like to welcome, and please join me in welcoming the panel to the stage.
The clicker. Oh, you want to save that for Mark? Yeah. Just the green button. Yep. Okay. So on behalf of my colleagues, we're really excited to be here for the next 40 or so minutes. So my job really, I'm just going to kind of set the stage a little bit. I have just a few slides, a few movies just to give a little bit of background, and then I'm going to ask really hard questions of my colleagues here. We each come at this from slightly different backgrounds, so we're just going to take like 30 seconds to tell you a little bit about what we're doing. So I've been an academic now for about 20 years. Early in my career, I was all about aerospace systems, space systems, satellites, and UAVs, and like any good academic, I had the students pull me in the direction of autonomous driving roughly about 10 years ago in something called the DARPA Urban Challenge, so Aaron was part of that team. So I listened to them and have been working sort of in that domain ever since then. So with that, Aaron.
Yep, so as Mark said, I kind of was one of the people responsible for pulling him in that direction of autonomous vehicles. I previously was working on tiny robots, and when they mentioned cars that were going to be driving themselves in the DARPA Urban Challenge, that was just too much to pass on. So I basically have been working on that since, and now am running a company where we're solving literally the problem of figuring out where all those autonomous cars are on a map. So.
So as a product manager at Nvidia, we're heavy into deep learning, so I spend a lot of time with some of the deep learning stuff, but I work with the automotives from a very different angle about actually designing the car. So they use the tools that we provide to help create the car, planes, trains, any of that automotive, any motion type thing they create. So that's my angle of this.
I'm trained as a roboticist, but these days I work for the RAND Corporation, which is a nonprofit think tank, and I'm asking big questions. How is this technology going to shape us, and how are we going to shape it? And how do we get a future that we want instead of one we really aren't looking forward to?
Okay, great. So we'll get started here. So just going to show you a couple slides. So the first one here, there's a couple of pictures, or a couple of movies. So the first movie, it's really maybe a little bit hard to see, but this is from our autonomous car driving up College Avenue towards College Town. So at least some people may remember that fondly. And in there, it's a 360-degree camera, so it's a camera that can see all the way around, as well as you see all the colored points right in between. So that is laser data, okay? And it's a 64 scan laser that rotates. So this is the raw data that's actually coming from the car, an example of it. So there are other sensors like radar and those types of things. But the point is this is kind of what the car sees. So it's just a lot of raw data. It's very easy to generalize. So the goal here, if you look at this sort of block diagram conceptually, is we want to take all of that data and then we want to convert it all the way to actions, right? So you have to typically go through several different building blocks. There's different ways of doing this. Some of it is learning, some of it is coding rules of the road and those types of things. But the bottom line is you have to go all the way from one end to the other. So I actually found this video online, and so really what you'd like to do, sort of our goal, is to automate a lot of the processes of autonomous driving. So if you take it all the way to automated intersections or smart intersections, they might want to do something a little bit like this, which is pretty slick. So if you just watch this for a little while, this is the future, right here. I think I'm the runner that goes across that just ignores everything like that. And so I often get asked why Cornell doesn't drive our car on autonomous roads, and really our lawyers look at this video and it's like, okay, that's enough. It just can't do it. So at least gives you a little bit of an idea. All right. So there's a lot you could talk about for background, and really we want to be a little bit more forward-thinking in this panel, but what I do want to talk about is really what I consider kind of one of the inflection points of autonomous driving. This was a set of 3 challenges called the DARPA challenges, and if you haven't heard of them, there was 2 that were, I think in 04 and 05, and then the one that I'm most familiar with is in 07. And the first 2 were driving across the desert out here in California, and mostly led by academic teams. There was a prize at the end, but typically not a lot of funding. But then the urban challenge was a little bit more unique in that DARPA gave $1 million to 10 organizations, and we were one of those organizations that received that money to build the actual car. And then there was other people who could actually partake as well. And so it roughly was a really quick approach, about 15 months to kind of beginning to end to kind of develop the autonomous car, and the goal was to drive about 60 miles. So what you see on the right-hand side of here is 2 things. One is the starting gate for the finalists who actually made it through each of the site visits and the semifinals and made it to the finals, and they were safe enough to drive. And then the top is our car called Skynet. So if you know that name, then you're well, you're kind of dating yourself, but it's pretty interesting anyways. So I just have 2 videos just to show a little bit about Cornell in this space, and they kind of relate to my memories of where I was. And so the first video on the left is very dark, and that's because it was at 2 a.m. in the morning. So I'm leaving work, and my students are saying, okay, we think we can actually do this, and some of that, and they're going to get a phone call. And so I'm driving out to the vet school parking lot at 2 in the morning, and so this is the car driving, right? And you'll see the videos you can see right now is on the inside. And you're going to be able to see the steering wheel kind of shaking and some of that. So this is the very first time that we were actually driving the car. So you see where it is, roughly a little over 10 years ago. And, I've worked in control loops and experiments for many years, but there's something about getting in a car that big and actually having it drive on your own. So it's pretty wild. But the thing that really kind of struck me is sort of this next video, and that is we just kind of flipped the switch and said, okay, now drive backwards, right? And most of us have driven backwards and everything like that, but driving backwards, going 15 to 20 miles an hour, okay, it's really freaky, and it just shows. It was the first thing that really struck me in that. The car's not afraid of that. I didn't care about any of that stuff. All it did was we just flipped the sign on the path of where we were actually going. So it was a very interesting process, and that was really, at least one of the defining moments for me, kind of understanding of where things would go. Okay, so the next slide here. So again, we were part of the finalists, one of 6 teams to finish, and we had a really nice process of that first part of that block diagram, which was sort of sensor fusion process and things like that. So really the students did a very, very nice job with that. So on the right-hand side are some video highlights of the car in action. I always like this part. The DARPA officials are behind really cement blocks and everything. It kind of tells you what they were thinking at the time. And there's a bunch of pictures on the lower left, the team and things like that. And this is Dean Huttenlocker. I don't know if Dan is here. He's looking really smart. We took the car down to the Pentagon in the courtyard and basically had a show and tell with people down there. This slide just gives you a little bit of background, at least some terminology and things like that that is out there right now. It was started from the Society of Automotive Engineers and the Highway Safety Board now has adopted this. And you'll hear terms called L4, L5, and these are called the levels of automation. And thanks to Ankit for putting this slide together. He found some interesting conceptual pictures of what each of these things are. And of course, I can't read the small print in terms of 0 through 5 and things like that. But roughly, there's a couple things you want to understand. At the beginning, the upper left 0 is when is basically, the Model T is basically the first cars that were driven. It's completely human driven, right? And then you have this spectrum that goes all the way to the very end at the next one. So 1 is a little bit of automation, which is typically cruise control. 2 is a little bit more of what on a lot of cars now, which is adaptive cruise control and things like that. And then really 3 through 5, you switch to this green area, and this green area is really when the car can take over and fully autonomously drive for you, okay? So the picture in the lower left basically means that you can take your hands off the wheel, but you have to be at the ready. 4 is fully autonomous driving, but the human can take over whenever he or she wants to do it. And then 5 is fully autonomous driving, but you don't have a steering wheel or anything like that. It's basically you get in and go. So it's almost like similar to a train and things like that. So I'll show you a couple of videos now from Nvidia. So Nvidia's in this game and working on a variety of things, but certainly one of the things they're famous for is taking the deep learning concepts and applying them to the autonomous driving. And so really pushing the envelope on this aspect of it. So this is a video of their car driving, and it's looking at the perception model. So what you see here is they're taking all that data I showed in the very first video, and you can see different elements. You can see boxes around cars. You can see the lines. The space out in front is basically the driving space. So that is avoiding collisions and those types of things. So really, this is the process of taking that gobs and gobs of data and converting it into usable information that you can then make decisions at. And you have to actually do that pretty quick. So if I move on to the next video, so this is their car just kind of operating. A lot of people see cars operating on regular roads and things like that, but this is an example of driving through a construction zone, which is a bit more challenging. So there's different elements to this video. I think the next part is driving through New Jersey, which is also very, very challenging. Yeah, sorry about that. I live in New York. What can I do? And so, there's these things. There's getting on the on-ramp, of course. So you have to merge and understand where all the cars are around you and those types of things. And then as you move on, they're getting to the bigger challenges. So this is driving at night, of course. So if you use vision, it becomes a little bit harder. Here it's driving on kind of a dirt road. There's weather conditions and those types of things. So certainly there's some corner cases and challenges that are still out there, even though there's a lot of cars that have been driving on the road for a while. Okay. So last slide, the real question that sort of this panel is going to kind of address is where will our cars take us? And certainly there are technology questions, and I think we can answer, or we can at least project what we think some things could actually be there. The L5 cars, so the L4 and the L5 cars, again, what will the mix be? L5, again, are the cars without steering wheels, and L4 it can be either or. The automated highways or trucks on the highways and stuff like that. But the real, the other question to really think about now that it's, out there in the space and really people are thinking about it and talking about it more and more is how can this change our lives? In what dimensions can this change our lives, right? So certainly there are things like taxis and Uber and those types of things, right? And those things might be automated. But will we have more green space? What will parking garages look like? What will cities look like, right? So these are all things that are going to be kind of interesting to see how it goes. Okay. So that's sort of where we are. So I have a couple of hard questions that depending on what kind of shows up on the screen. So you have kind of a high bar if you want to kind of do that. So the first question I'll throw out to the panel is it sort of builds on this last slide, which is what will the cars and trucks or maybe even cities look like 10 years from now? So in 2027.
Sure. It depends, and unfortunately that's always a question. It depends on what we do with them. My hope is that right now, our cities are organized around the vehicle. They are made so that automobiles have a good time. And my hope is that in the future, they will be designed so that we have a good time. So not only do we not have parking garages, but instead of 4 lanes and it's really hard, you're a pedestrian that's being cursed at by drivers, really this is a city designed for the way people want to live. And so we use our land differently. We drive when we want to drive. We go places differently based on what our interests are. And so my hope is that our cities will be more efficient, have better land use, cleaner, really places that we're excited about being rather than having our cars get excited about it.
On the cars themselves, I'm thinking that you'll end up having both, right? You'll have level 4 and level 5, just because as humans we kind of we want to have control, right? We had autonomous, I don't call them vehicles before. We had horses, and you still have reins and things on a horse because you want to feel like you're in control, even though the horse is really not going to jump off a cliff or any of that stuff, right? So I think you'll still have that, but I think it'll depend on the number of people you're carrying, like our trains. And I don't have any control when I'm on a train. So if you're in that type of an autonomous vehicle where you're moving a lot of people, I think you'll have like level 5 where there's no sort of interface. But if you're kind of by yourself or small groups of people, I think you will want that control.
I think one of the interesting things about this space now, as opposed to like 10 years ago, 10 years ago when we fished the Urban Challenge, who we were talking to, I remember there was workshops after the Urban Challenge, and we were basically talking to the car companies and stuff like that. But the landscape is completely different now, right? So Google's involved, Nvidia, maybe Apple, I think what that shows you is that the concept is different, right? And when I talk to different companies, it's very interesting hearing people talk about it. They talk about it more as a product, almost like your iPhone or something like that. So when you think about some of these things, they're more customizable, right? And customizable to your needs, your experiences, those types of things. And so it's interesting to think about sort of what the future will look like. So another question is how do you build quality self-driving software, which is sort of one of the key challenges these days. And certainly the previous speakers were talking a little bit about software and learning and these types of things, and all that stuff is going to evolve. So maybe we'll start with Aaron with that one.
Sure. So I would say that it's pretty well understood that the way to build quality software is by testing. That's been proven in all types of software, whether it's building internet software or things that are in self-driving cars. And so the question really becomes, how do you test these self-driving cars? And we've all been testing self-driving car technologies and just car technologies for pretty much since cars have been on the road. We've all been kind of early adopters of everything from cruise control to what you've seen in kind of the more modern ADAS systems that you see videos of people on YouTube with their hands off the wheels driving down 280. And I think that you're going to see a lot of that, but as vehicles become more connected, car companies are going to be able to start to use more of that data to actually start to train their own systems about how can we actually now test against all these situations where we had to sound the alarm that says the human has to take control. And that's where we'll start to see, I think, a really exponential progress in basically the data that we'll be able to have so that we can train these models and basically have more reliable systems. So.
Yes. So I think I agree with you, but I think that you just can't have all the situations, right? Like I can imagine 7 situations probably that if you just Google, probably I haven't done this, but if you Google crazy accidents or something, I'm sure you'll see these things that you never thought of. We can plan. Oh, maybe a deer will come out, or maybe we're prediction systems, right? So we can predict so much stuff. There's always new stuff, and so I'm going to propose that I think simulation is going to help a lot, right? Being able to simulate, so have synthetic data, because you have stuff to do things that we were talking about earlier, regression testing, unit testing. So you can do all that type of stuff only in a system that has that you can actually create these scenarios that just may not ever exist in real life. Oh, what if an asteroid hits? I don't know, I'm just making that up. But it's like you can simulate that. I'm sure you can't video that, but you can simulate that, right?
Well, let me throw a little numbers behind what you're talking about. People are wondering, well, how safe are autonomous vehicles going to be? And the answer is that until we get real people in them, we actually might not know. Mm-hmm. And the reason for that is, let's imagine we have a fleet of autonomous vehicles that are 20% safer than human drivers. To test that, to actually drive those number of miles, to statistically test that would take driving 5 billion miles, which is literally driving to Neptune and back, and again and back, because you forgot something on Neptune, I don't know. And that is enormous. For a test fleet to drive that, with trained drivers behind the wheel, would take 200 plus years. And we're not going to wait that long. So we definitely need another way. But the interesting point about that is that actually Americans drive 8 billion miles every single day. So once people start using this technology, we're going to know really fast whether it's safe or not. but that's the rub, right?
So, well, okay, so one more comment. There's maybe a policy thing, but when I got my driver's license, I got in behind a car. I was there with the instructor. I probably drove maybe, 20 minutes or something, and they said, here's your license. You're legally allowed to now drive around wherever you want. There's not a lot of testing on me, right?
But it doesn't prove that you're a safe driver, right? It just says, we're going to let this guy drive. We'll hope
So
he
that's why I said
gets
it's a
better, right?
policy thing, in that, like how will you, we're probably being a lot more stricter on self-driving cars than we ever were on
People
ourselves.
accept mistakes from other people. We empathize. Oh, you screwed up. You were busy doing this other thing. With machines, we expect them to be perfect, perhaps to our detriment.
I think the process of, there's definitely big emphasis these days on learning, right? Because it's one of these things where you could code up the rules of the road typically fairly easily, right? But then there's all these corner cases and problems that are really challenging to kind of work out. But the learning aspect is really challenging. How do you know if you put in like a new learning algorithm that's going to better and better and better, that it doesn't affect something else in what you're doing, right? And the example of you getting your permit, I mean, it's a good one. I mean, I have two teenagers, like one could drive, and the other one is going to get his permit in about a month. And the first 2 months, with my daughter, we're like, well, this is very interesting, right? And but the hope is that she was learning, and the key element of what, in my mind, when I kind of relate it to people, is that we were teaching her the skills of driving, right? But then if I would put her in another environment, once she's kind of learned that, she can actually drive, right? And right now, I think the cars aren't quite there yet, right? I mean, they typically have to have really accurate map data to get rid of all these uncertainties, or have to learn on a set of data, and then if you throw out something new, it's a little hard. And so really, these are some of the challenges I think that are sort of coming out in terms of what's
That was
in
in the previous panel, right? We talked about having general purpose AI versus like the AI that we have right now is very specific to a task, but not general enough that you can take something you learn here to do something else.
Right. So I was looking at the questions and they were really tiny print, and I'm like, there's no way I'm doing this. But then somebody was like, yeah, okay, then we can actually do that. So let's take the first one. So are regulators and insurers welcoming of L4, L5 cars? And if not, what are the challenges and how does the industry overcome them? So, I don't know.
Sure.
Go for it.
No,
You go for it. I'll say insurance, you talk about policy.
So I work a lot with regulators and insurers to think about this, and so most regulators and insurers are very excited about the technology, but it's also scary because it changes the way they think about what they do. From a regulator standpoint, one job is to facilitate innovation, create new jobs, improve the economy, grow the economy. On the other hand, they're on the hook if something goes wrong. And so there's a risk aversion there too. And so regulators are welcoming, but they're concerned, what is my role here? How do I get the right regulations for disruptive technology without stifling that? Insurers are also excited, but it really completely changes what insurance looks like, because who is insured? If a GM vehicle crashes into, a GM autonomous vehicle crashes into, a Toyota autonomous vehicle, is this going to take like 4 years in court to figure out, how your claim gets paid? So things get really complicated. What's your take on it?
I was going to talk about insurance and predictability, right? So insurance is all about, you got these really smart math people that figure out exactly what the probability is. Okay, a 16-year-old who just got their license is not as safe as somebody who's 40 and has 2 kids and is probably not likely to take risks. But when you look at an autonomous vehicle, and the two things that people mostly do in their cars, one is they commute to work, number 2 is they go shopping, right? So those kind of the 2 big things. So if you can map that, so I just think that it's easier to predict, and so I think insurance companies are looking for it because they like to be able to predict it, so that kind of, the better you can predict, the lower you can, the more you can drive down your risk. And so if you can drive down that risk, you can increase margins, although you can also have new entrants that are really better at predicting that stuff and hurt them. But yeah, I was going to refer to that as our insurance companies are welcoming.
Yeah.
And I mean, you're already starting to see it. There's insurance companies that you can plug a little module in your car and it gets them extra data. I mean, basically, data helps them lower risk,
right.
And they love that. So there's no question that they will like autonomous vehicles for that reason.
All right, so I'm going to take another from the list that we had beforehand. Who will be the winners and the losers in the transition to self-driving cars? So.
All right, let me take one. All right, so back to B school, porters. Let's think through some of that stuff. To work through this, what data point? So 260 million cars in the U.S., and something I read somewhere else was that cars spend about 95% of their time in parking lots, right? So 95% of the time they're just parked. So 5% utilization of 260 million vehicles. So if we increase that utilization, assuming it's autonomous, I can have one car instead of two. I can have it drop me off at work, go back, pick up my wife or whatever, and do what it needs to do. So let's say we increase utilization to 10%. That's 130 million cars lost. So I think that the car makers are going to have trouble with that. So in terms of losers, I think there's going to be I predict, unless they figure out some sort of consolidation, because that industry is going to become less profitable. You look at the airline industry, it's a crappy industry. It looks nice, but it's a crappy industry in terms of profitability. And it will end up in a similar situation, because when you look at buyers won't be me and you. Buyers will be Uber or Lyft, and they're going to go there and say, hey, look, I want to buy a fleet of about 100,000 cars. What's my price? And when you negotiate with that, obviously it's going to be very different than what we can do, and the profitability, I think, for them. Therefore, I think the auto guys are going to be losers. But they are working on things like auto companies are looking at probably offering insurance. Auto companies are looking at all the data they're collecting. Can they monetize the data? So we'll see.
I think I've heard this a bunch of times. I mean, there's people working on the hardware, there's people working on sensors and those types of things. But very similar to the internet and some of that, it was the companies that had access to the data and those kinds of things, access to the user experience, which was kind of key. And so I think there's, at least from my point of view, I'm an academic, what do I know? It does seem to me that the companies really want access to the users themselves and the data, right? They just don't want to build cars, right? And that's a key element of what's going to kind of happen in the future, I think.
I think we can't have this conversation about winners and losers without acknowledging the job loss, right? I mean, that's really fundamental, which, in some states, being a professional driver is the #1 job. And it's one of the few ways with people without a higher education degree can have a sustained livelihood. And this is not just with autonomous vehicles, every kind of robotics, automation, every, structural change in our economy and technological change brings this on. And particularly in today's policy and political climate, that's a problem that we need to pay attention to. It's sort of, I think it's inadequate to say, if you want to have an omelet, you got to break some eggs, because those are people's jobs and livelihoods.
Yeah.
But we don't see many answers to those questions.
Yeah, and you made a good point about, we're talking about cars here, but yeah, anything that moves is going to be autonomous, right? You have my lawnmower, well, I don't have a lawnmower, but a lawnmower can be autonomous, same as your Roomba, right? Everything that moves is going to be autonomous at some point using the same technology.
Yeah, that part is definitely a big question. I do think, though, just moving back to the original part of, who's going to win in this space, you do also have the vehicle become now a platform for a captive audience, because now, you have to think about why are companies like Google, that traditionally is an advertising company, thinking about autonomous driving. It's, well, sure, that'd be a great thing to have, but now you have literally someone that you have effectively complete control over while they're in this vehicle. It is a physically captive audience. So that is something that I think, the value of that is, it's a whole new platform. It could be bigger than the iPhone as, a place to deliver content.
And it's one of those funny things, it's hard to predict, right? Like when we had cars, and we were doing things with cars and stuff, but nobody, we predicted that cars would take us places, we'll do all sorts of things with cars, but no one really predicted that you'll have Walmarts all over the place, and that Walmart's going to be a huge winner from cars, right? Cars kind of, if I didn't have a car, I would never go to Walmart, buy too much stuff. Walmart's an example, but I go to Costco.
I think if you think about all the reasons that you have a car, I'm not sure if people have these discussions, but I know my wife and I have had these multiple times, is that we always debate what kind of car that we want. Do we want high gas mileage? Do we want a big car? Do we want a small car? For a while we were trucking the kids to soccer and tennis and dance and everything like that, so we wanted a bigger car and things like that. And I think that model is going to change, right? I think people, will want a commuter car, but maybe they'll want to commute with other people, but maybe we'll have an a la carte thing, right? So if you only need a minivan for a couple of vacations a year and you really need it, then maybe you have a commuter car, but you trade that in because there's a new model now for you to be able to kind of do that. So I think certainly the way that the user experience is going to change, which is a big part of it. But I think just the whole dynamics of cities and how we utilize and think about cars is going to change as well. So,
And from a mobility standpoint, people, older people who face losing their license, people who have disabilities and can't drive, and also people who are who struggle to have affordable transportation or high quality transportation. If we think about autonomous ride sharing like Uber and Lyft, suddenly the cost of a trip becomes so low. And research shows that access to good transportation is one of the most important enablers for economic mobility. And so this may actually really transform what people who currently don't have equitable mobility can do, and may change their lives in really profound ways.
Yeah, that's a good point. So I'll take one of the questions from here. So what are your thoughts or concerns about tampering or hacking? We were actually just talking about this at lunch before we started. I think the answer was, I have no idea.
That's scary. Let me go. You go first. I'll talk about deep learning. I'll talk about deep learning kind of thing.
Okay.
So in the way the deep learning stuff works is you have all these, and we talked about neurons before, so you have all these layers of neurons, and they all have some sort of a statistical weight. And so that's kind of this IP that you keep, and that's that's the brains of how it works. It's all just weights and probabilities for things. And so if you could hack and change those weights, right, it's actually pretty scary what you can do. And one of this very cited papers in deep learning talks about you can have a picture of gibberish. Like, it's really just a bunch of random pixels. You show it to a computer vision algorithm, and it says, oh, that's a cat. But it's just a random bunch of pixels because they knew what the weights were. So even if you don't change the weights, but you know how the weighting is being done, you can actually hack the system, not by infiltrating it, but hack it from just the environment and from the inputs that it's getting. So that's pretty scary, and I have no idea how to solve it.
Yeah, I think there's actually two sides to this that I find very interesting. So Mark showed in the beginning that kind of laser, the rainbow picture of how a car sees, and fundamentally it's very different from how you and I perceive the world. And so the real problem with this is that exploits, basically these things that confuse the cars, will be very difficult for us as humans to detect. I happen to work a lot with GPS, and that's one of these invisible signals that's important for this autonomous vehicle world. And basically, there was this very famous case where at Newark Airport, they used GPS to help land planes, and this guy kept driving back and forth with a $5 GPS jammer, but they couldn't catch him because he was driving on basically one of the highways that was just, up and down, and he had a daily route that at, 9 o'clock in the morning every day it would get jammed. Eventually, they caught this guy, but it took them months to be able to do so. And those are the kinds of things where just signal interference that we don't perceive could literally have very profound effects on these somewhat fragile systems. It's a big thing to think about.
I think, so I have a research project with a couple of colleagues in electrical and computer science in this. And it's a really, from a fundamental research standpoint, it's a huge focus, because I think people are really starting to think about it. I mean, a number of years, maybe 3 or 4 years ago, some people published a couple of papers on 20 different ways of hacking into a car, right? And it's so simple. And this is previous cars, whereas the future autonomous cars will have data streamed and everything like that, right? And you'll be more and more interconnected. So it's a scary thing, and it's really important. And I think there are some strategies for kind of dealing with that. I mean, I think there's certainly this idea of having multiple sort of backup systems, so multiple information sources coming in, so that you can verify each of the data streams coming in. So that's certainly an important thing. Another way is that you can try to protect sort of the inner side of things. So for instance, the number one thing would be collisions, right? And making sure that you have sort of an inner loop piece of software and sensing and those types of things is very, very well protected from a lot of these data streams that are actually coming out. So I think there are some strategies, but I think it's a huge deal. If you even take it further, and so the movie I showed at the beginning, sort of the joke movie about the intersections and stuff like that. I mean, really, one of the aspects that people have been looking at would be automated intersections, or intersections that are very, very dangerous, making sure that they're sharing information as they go through to kind of avoid accidents. In theory, that sounds awesome to me as somebody who wants to prevent accidents and things like that, but it seems like a huge security liability, right? It's very easy to hack into this, into the system, and be able to just tell one car to kind of, go one direction, not the other. Now, there are, I think they can take lessons learned from other places, certainly like the airline industry and those types of things, and where there's a lot of, vehicles that are flying in the air this time. They're a little bit more well separated typically. But certainly there's some lessons learned there that I think they could kind of take advantage of.
And Mark, if I can scare people a little bit more. We talk a lot about hacking and security. What people are really wondering, what's underlying that question is, how can my autonomous vehicle be used for nefarious purposes? And so I'll just paint this picture for you, which is that, imagine you can load up a car with explosives and program in a destination, and it goes on its merry way. And I am not actually trying to scare you, but it's a very real possibility, something that law enforcement is concerned about, something that Homeland Security is concerned about, because this is a new technology, just like drones, for example, that can be used, used by terrorists or, people who just want to cause mayhem. And so there's a lot of different ways that this technology creates security problems, and we're only just starting to come to grips with our imagination, really.
Okay, so I'll take questions.
You're welcome. You're welcome.
Silence. So this question, I guess, is a little bit more about different kind of countries. Maybe we can expand it in terms of that. So what are the economic partnerships you would need to overcome or build in order to get a whole country to switch automated cars? I think we can maybe expand that and even talk a little bit about how different countries focus on this, whether it's the US versus China versus Europe or Germany or something like that. So.
How do we get the whole country to switch? I think there could be regulatory approaches, but really it has to be that people want it. It takes, our fleets take 30 plus years to turn over because it's expensive to buy a new car. People make these decisions for a long term, and cars have a long lifespan. But if we move to a mobility as a service model where people don't necessarily own cars, but they have mobility, if people can do more, they enjoy more, then it can be it doesn't have to be a regulatory thing at all. In fact, it probably shouldn't be. Just as we don't need regulations that demand everyone get a smartphone, right? That's just, everyone says, wow, this is so great, I need one. And so it seems like, it's not clear to me that economic partnerships are needed. Really, people just have to develop a technology that people want to use.
So it's an interesting question. Do you think it's possible for a country similar to having healthcare, say, all right, we provide transportation? Like it's the country provides transportation.
It's actually a great question. So I was testifying recently at a congressional hearing, and the question came up that someone raised a question: is transportation going to be the new entitlement program? Mm-hmm. And I can imagine that in some countries people will see transportation as a fundamental right because of all the things it means for us, from our well-being, our economic mobility, and so on. It's not clear to me that'll happen in this country.
Some countries.
But
yeah, so that's exactly where I was going with that.
Yeah.
It's possible that a country would say, all right, we're going to take it over, and transportation is now just done by the government, and you don't have to worry about it.
Right, or it's subsidized by the government such that everyone has it as a right, and could happen.
That being said, I do think that there are going to be things along the way that get us there. So there's, we've had seatbelts were the first thing that came in. This is mandated safety. Then we have airbags, and now ABS and things like, tire pressure sensors. We're going to now have front collision detection is going to be something that's regulated by the government. I do think that those types of micro pushes are very important to basically getting the technology there. So now the cost of all this stuff starts to come down and basically be accessible.
And I think we're going to reach a point, not maybe in the very near term, but we'll reach a point where it becomes actually dangerous to have a human behind the wheel. And just as I can't ride my horse down 280, I'm not going to be able to get in my car and drive because I'm creating a public hazard for everyone on the road around me.
You're drunk driving, right?
Yeah,
Drunk driving,
exactly.
same thing. Public hazard.
What about a city, though? What about, so maybe we scale it down a little bit. So it's hard for me to imagine New York City saying, okay, all cars are autonomous coming into the city, but maybe Beijing?
Mm-hmm. LA has proposed, there's a proposal on the table to pave the way for LA to be largely autonomous or fully autonomous soon, because I think cities recognize that this is transformative for them. And either they can have a role in shaping what this looks like, to have electrification, sharing, clean air, better use of their land, or they can, just let it do what it does, and it may hollow out cities on the other hand. So I can actually see some cities going that route, but comes a problem when you're a tourist and you start visiting that city. I don't know what happens.
So you need that
So they don't wanna cut out the
interoperability.
tourists.
Yeah.
Interoperability is going to be a problem.
Okay, so I think we only have about 3 minutes left, so I think what I'll do is skip to the last one here. So what are and maybe everybody can weigh on this, what are the one or two key either technology innovations or policy changes or other factors that really will get self-driving cars in everybody's here's hands? So, I don't know. Ankit, do you want to start?
Sure. So I'll take an easy one in the senses, and I already know it's happening. So we talked about, those, when you see the Google self-driving car, you see that little bucket thing at the top, that's a LiDAR, and those things are super expensive. super meaning like tens of thousands, maybe 50, I don't know how much it is, like $50,000 or $70,000, something like that.
$10,000 now, yeah.
Oh, $10,000 now, but they're talking about getting it down to hundreds of dollars. So basically putting it on chip. So once that stuff comes down to hundreds of dollars and it's everywhere, I think that having LiDAR plus camera plus radar plus GPS and having all that information together is going to give the car enough data to make a decision. So I think that's going to be pretty important as far as a very soon technology. So it's a short-term thing.
Okay. Yeah.
Yeah, I'll echo, basically the cost is going to be the biggest innovation that needs to happen. And so, one approach is to wait for these LiDAR sensors to get cheaper. There's other very innovative companies basically using cameras only. Maybe Nvidia might be one of them.
Oh, we're sensor agnostic.
Yeah, and basically the idea there is that if you can get this to be extremely inexpensive and deployed onto lots and lots of vehicles, then maybe you can actually get there faster than putting lots of very expensive things on a single vehicle. Either way, it's all going to be about basically bringing the cost down so that we have this large data set to work with.
From a policy standpoint, I mean, this technology is coming. And my concern is less with how is it going to get on the roads and more concerned with how are we going to get it to do what we want or create a city or a future that we want. And so I think the innovation needs to be on creating the right incentives for people to use the technology and for developers to make the technology in a way that meets a lot of transportation goals that have stymied us for so long. Equity, clean energy, reducing congestion. These are the things I think that we need to start innovating on so that when the technology hits the roads for real, we're ready and we're ready to use it in a way that makes the future better.
So I'll finish up with just two comments on that, and one is on the technology side. I think where things stand right now is that there still needs to be a human driver. So I think one of the questions that came up here is, what happens if something comes up that was unexpected? And the answer is the human takes over. That's actually what happens right now. So I guess it depends on what you define on, getting autonomous cars or self-driving cars in people's hands, right? So if you define it as it can handle pretty much most of the situations, then there's a certain level of brittleness to cars right now, or at least the software and handling unexpected situations that it just can't handle, right? And it could be a GPS outage. It could be that you're driving a road you've never driven in. It could be, some sensor outage or something like that. So until those are solved, and that's a little bit more robust, I don't think we're at L4, for most consumers. I think that's just not going to happen. I think the other interesting aspect of this, at least from the, I'm not sure if it's policy side, but is really, the insurance companies are going to weigh in on this, right? And it's always, I think of it as a technology person and how you're programming different things, and you can see, there's going to be decisions you're going to have to make in an algorithm that are going to be hard, it's going to test your ethics and things like that. So it's going to be kind of interesting to see where it goes. And then, so I think the insurance companies are going to kind of drive some of this and weigh in on this a little bit. I think Aaron had a good example of there's sort of this phased way in, is that, yeah, you can pay a little bit more insurance to drive an L4 car or something like that, which I thought was a kind of a good way of doing it and stuff like that. So, so I think that's it. I think we're out of time. So thank you very much. Appreciate it.
Thank you.